What was the easiest out of all of this? Well, hopefully this. You guys tracking on the nuns? Why are those nuns again? Because what's the domain? For any polynomial, all real numbers, which means I don't have to worry about any, what are these guys called again? Discontinuities. Good. Discontinuities. We have non-removable and removable, but we have none, so none, none, all real numbers. What else was easy? What was your f prime?
4x cubed minus 36x squared plus 96x.
Ooh, do any of you ever sometimes forget the power there because you're like going too fast? I've graded your test. Yes, you do. Okay, next one. 96x.
Minus 64. Minus
64. Okay. How about f double prime?
12x squared minus 72x.
And then Kyle, you said this one's easy because the y-intercept says plug in x is 0, and what do you get?
0.
Perfect. Which means, isn't one of the x-intercepts also 0, 0 because the origin hits both axes? You could also pull out an x and see that 0, but what was the dilemma next? Struggle. Okay, so hold on. I was just asking you to find as many things as you could. What else could you find? Are finding magrits easy? No, because what do you have? I have a cubic. Now you could pull out a 4 and make it a little bit easier, right? 4 would go in 24 times, and 4 would go in 16 times. Aww. So hold on, wait a minute. We're allowed to go in whatever order we want, right? So anybody figure out there was no symmetry? Why, Adam?
Because, like, when you plug in the positive and negative signs change, like, different. They don't all change in the family or all stay the same.
Because anytime you have an even power, what's going to happen? It's going to stay the same, but then as soon as you go to an odd power, it's going to... So you're going to have like same change, and they're all going to be like, no, there's no opposite or same there. So symmetry was none. How about horizontal asymptotes? Degree test. Top wins, there's a 0 in the bottom. It's 1 times x to the 0, so that's a none. Top wins by 1? No, it wins by like 4. Okay, none of those. Man, everything's easy except for, I don't know my other intercepts over here. And okay, so then is there anything we can do over here?
No.
Crits are hard, but what is easy? How about pips? Now some of you are like, easy. Well, okay, we've set equal to 0. It's just a polynomial, no DNEs. Can we pull out a 12?
Yes.
What do we get when we pull out a 12?
X.
Ooh, that's not too bad. I don't mind the pips as much. Keep factoring, and you got? Come on, you guys are algebraic enough that if you were to do a factoring, you always double check and make sure you have the right one, right? X squared minus 2 minus 4 is minus 6, and then a plus 8. Got 'em. What does that mean about my pips?
4 and 2.
4 and 2. So I could do my concavity pretty quick. If we're doing our concavity sign chart, should you guys be plugging into this guy, just strategically, or this guy?
Bottom guy.
Yeah, why? These little multiplications are so much easier than squaring times 12 times 72 plus... Here, so much easier because it's a times, times, times. Positive, 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 negative. Anyway, let's check it. So we have our 2, we have our 4. Any domain problems to put in our sign chart?
Nope.
Nope. 0 looks easy? Okay. What's going on when I plug in 0?
Negative 4 times negative. It's positive.
Positive. Does that make sense? Cool. How about when I plug in a 3? Negative times a... And then he's on. Okay. And then I plug in a 5?
Positive.
So I have concave up, concave down, concave up.
Well, you have 2.
I do have 2 points of inflection. My points of inflection are going to be at, whoa, why am I putting 2 sets of parentheses? Because I'm doing the actual points. So if I have the x's, what else am I supposed to be able or need to fill out my points? I need the y's. So the y's, when I come on up, the y's are going to be at, you guys know what we have to do is plug in, right?
Yeah.
So could we plug into the first? Yes. Could we plug into the second? Yes. Is one particularly easier than the other? I don't know. It's up to you guys. When we plug in, what do we get? Sometimes it's easier just to write it out. We have 8 minus 48 plus 96 minus 64. Is that right? So I do my negatives and my positives. I don't know if that's what you guys, if that's what you guys would do, but I have 104, and I have minus 112 times 2. Oh, that's not too bad, because that's just negative 8 times 2 is negative 16. Double checking. Okay. Isn't it ironic? The addition and subtraction is what we get frustrated at. The derivative was the easy part. Plugging in the 4. 4 cubed is 64. 4 and 4 is 16. 16 and 12. Is anybody in their head to do 16 times 12? Are you doing 16 times 10 and then plus 16 times 2? Anybody realize that's a lot easier? So that's 160 and then that's 32. Anyway, minus 192. Plus 48 times 4 is 40 times 4. Which is 160 plus 32, so 192. Oh, look at that! They go away. And then 64.
Hello?
So we just fine.
An x-intercept.
Did you see it?
God.
Now, does that always happen? No. But does it make our intercepts easier? Yes, because check it. Cancel, 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 cancel. I just found one. Okay. Wait a minute. How many of these could I have? Does anybody know how many x-intercepts there could be up to?
3.
A fourth is going to go either down and up, down and bouncing up, or what's the worst case scenario? How many could you have? 1, 2, 3, 4. I could have up to 4. I could have 0, because it's all above. I could have 1 or 2 or 3 or 4. Well, I have 2 so far. And I have my points of inflection. What are we actually trying to do? We still haven't done increasing, decreasing, or extremely, right? We're supposed to be getting to a graph. Can we see how many things we have so far? We're trying to graph. You guys help me out. We have a point at 0, 0, right? We have a point at 1, 2, 3, 4, 0. Oh, we have a point at 2 and negative. Here, I'm just going to do by 16. Is that okay? 4, 8, 12, 16. 2 and negative 16. But what happened with our symmetry? Can we do any like copying cool stuff? There's a change in concavity here and here. Are we kind of still messed up? Yeah. Okay, so let's go back. What's true now that we found another intercept? What can we actually do?
Can we plug in?
We could plug in 4 and we get 0. What else could we do? Thinking about 3 count.
Complete square. Divide.
Plug in what?
The next one.
Well, we already have. I was thinking either grouping or I was thinking synthetic division. Because we don't have any like x's without y's, but we do have another clue that would help us break him down more, wouldn't it? We know that 4 goes in, which we already know the y is 0, so But we don't know what would happen if we took out the x minus 4.
Yes, let's divide.
So we could just do like a synthetic division and be like, or a long division if you want, with 1, negative 12, 48, and 64. Someone also said, why don't you group? So you have your x cubed minus 12x squared. What's in common? 48x minus 64. You could see if grouping is nice. I could pull out a 12, no, 8.
No.
I could pull out a 16. Do you guys realize these aren't going to match? That would be a 3x minus. Oh, they don't match, so I can't go any farther. So grouping was a good idea if it worked. But it doesn't. But this one's going to work, because what's my remainder going to be if I'm dividing by the dude that goes in? 0. And then I'll have a quadratic left, so I can bring down my 1. 60. Ooh, where's my negative?
Yeah, that's negative 64.
It's just on the
The top one's negative.
Oh, thank you. I just did put the actual negative sign here. Got it. So, guess how I can rewrite this? X times x minus 4 times x. Wait, hold on. Is this something I can maybe factor more?
Yeah.
Do I have any other intercepts?
No.
What the? Whoa.
Okay.
Oh.
Is there a way to recognize
So I'm done. There are no more intercepts. Got nothing else to do.
Minus 4.
Yeah. What? Not very easily, besides the fact, Adam, that right here I saw 64, which is 4 cubed, so I might have gone looking for 4s right away, and then looking for 4s without using the pip. Would have gotten this here, but sadly no. So the nice thing is we're done with all our pre-cal steps, but our graph hasn't added anything, right? Except, well, you guys might not remember this, but way back when in pre-cal, technically we talked about multiplicity of zeros. And if it was an even multiplicity, it bounces at that x-intercept, and if it's an odd multiplicity, it crosses through. Which you might not like me using multiplicities, but with the multiplicities, technically, I know that I'm somehow crossing through, and I'm somehow crossing through. Well, that doesn't help tons. Critical numbers then. What are we kind of messed up with unless we figure out? Pause. What did you love with this problem? What was the easiest thing ever? And how many nuns there were. But isn't it, in essence, ending up to be a much harder problem than yesterday? Okay. Are you going to face different examples in your homework, the one that's due tomorrow? Yes. How have I shortcutted all of your work? You do not have to take derivatives. You can open up my derivatives and just steal and use them, right? But is each different type of function going to have different pros and cons? Yes. Has anybody actually read the homework assignment yet and seen that I attached multiple videos in my PDFs?
Yes.
What are the multiple videos? Other years where I had tons of time to do tons of examples. So if you get to a problem in homework that isn't a polynomial, that isn't a rational function, or that isn't a radical function like the next example and probably the last example we're going to do, and if you get stuck on it, my advice, go to the video and scroll through and be like, wait, did she do any examples like it? And then pause it and be like, okay, I'll use what she does. Does that make sense? Okay. So in some ways, is this homework nice and easy because it's all review? Yes. In some ways, it's every function you're going to be able to say. So, okay, let's come back. We have to maybe use our factoring skills some more. I know it's annoying, but it's something that the AP can have us do. Kiddos, let's strategize together. We're a whole class of advanced math students. Can we tackle a cubic polynomial? The answer is yes. So give me some ideas. We need to factor this guy, or we need to find his zeros at least. Does anybody have any ideas about how to go? That's a cube. That's the whole reason it's a problem. Any ideas to go looking? Hey, Adam's thinking like, hey, the AP is pretty cool because sometimes you can just start plugging in stuff. Where else, Forever Card Time, where else was there a plugging in to try to get an answer because the algebra is too hard?
I think.
You just did corrections on a test that had this type of problem. The AB one. What's the AB one? Not like CalcAB. Derivatives of inverses.
And why it's
F prime of A is equal to 1 over F prime of B. And so you have the A, he's the Y. We have to solve for the B, which is the X, and so we have to sometimes just plug in, check, and test. What did Adam just do? Does 0 work? No. Does 1 work? Is it a yes? 1 minus 9 is negative 8, plus 24 is 16, minus 16 is... The AP is not going to actually expect you. Now, homework might. They might give you nasty ones. Lo siento, it's possible. But on the AP, it's going to be a plug and check one. Oh, sweet. Hey, since 1 works. I have 1, but how many different possible zeros are there to a cubic? So do I have to keep looking? Yes. How do I keep looking? Well, what did we do a second ago when we knew another factor and we had to break it down? Synthetic. If you don't like synthetic, could you do long division? I'm just showing you can do it whichever way you want. You could say I need to get rid of that x minus 1. It's up to you, though. If you know synthetic, it's definitely easier. I'm just saying, hey, you can break them down multiple ways. So if I break them down, remember, you distribute. It's a division problem, so we have to subtract. But we have to distribute that subtraction, negative 9 plus 1. Just in case you forget synthetic, you're not sure you're doing it right. And then there's a division problem, so subtraction. 24 minus 8. There we go. So now we know f prime is equal to 4 times x minus 1 times x squared minus 8x plus 16.
which is just x minus 2.
Sweet. What can we do now that we know my critical numbers? What are we looking for? These guys. Adam, what was that question that you asked me yesterday when we were talking about homework? Besides the whole, like, wait, you can actually just use the derivatives. It feels like cheating, but it's not. Do we actually have to find all of them? Yes. The answer is yes. But the nice thing is, next Wednesday, when you have one of these questions on the test, and it can be like any of these sample types of functions. Just hints, it probably won't be one of these nasty factoring ones because it'll take way too much time just to do the algebra. But anyway, when I give you one, I'm going to have all of these nice and listed. Does that make sense? So do you have to worry about like writing these out? Can you just say crits, I/D, relative extreme, pips, CU/CD. Poise is what some people call these POIs. I don't know why. Anyway, you can shortcut it, but yes, I do want to see the 14. If there's a none, I want it listed out. And if I don't see all that when you submit your homework. But how hard are the directions? Not hard. Because don't you just have to do like graph with 14 IDs? Let's go. Is that cool? If we plug in 0, where are we plugging it into? This? This? Let's plug it in here. Sound good?
Plug it in.
Okay, plugging in 0. I have negative. Isn't he always positive? Oh, sweet. Okay, so negative. If I plug in 2? And if I plug in 5? Oh. So he's decreasing. Increasing. Increasing some more. But he levels off here and here because these are horizontal tangent lines because they're zeros. So do I have any extrema? Yes. And where? I have a relative what kind? Min. As. Whoa, why is she doing a point? We always just say x equals, but guys, where are we trying to go to? A graph. I want to actually have the points to put in my graph. So I'm gonna go back to the beginning and actually plug in 1. What happens if we plug in 1 to the beginning? We already know 4. Plugging in 4 is 0. That's easy. But plugging in 1 minus 12, negative 11, plus 48, 37, minus 64, negative 27? Okay. Negative 27. Do I have any relative maxes? Yeah.
You know how like the second derivative test for like extra relative at double point was like less than 0
It does, so could we have just, once we found 1 and 4, gone to the second derivative and figured out the concavity and done it from that? Yes. At the first one, we would have had a positive second derivative, which would have been concave up, indicating the mean. The second one, if we had plugged in, we would have gotten a 0, which means, nothing. So we have 1, negative 27-ish, wherever that guy is. Oh, and he's a min, which means, so then I go here, and then I go here. Now, mine looks a little sharp. Should it be sharp?
No.
Technically not. Wait a minute, what kind of concavity am I supposed to have? I'm going to move all of my pre-cal work out of the way, because to be honest, right now it's kind of messing me up. Moving all my pre-cal work down to the end. Okay, what do we got? My function is decreasing to his min. Sweet. Decreasing to his min. Got it. Going through that 0, going to the min, coming up to the 2, negative 16, which is a point of inflection. So wait, it's concave up until here? Then what needs to happen?
Concave down but increasing.
Oh, so like this. Do you see the concave up changing to concave down? Okay, well, what needs to happen at 4? Concave down changes to concave up, but I'm still in. Wait. And then isn't 4 a leveling off place too? You guys see how it's going to kind of be like a tangent and kind of like a cubic? Dun, 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 dun.
Ew, that's disgusting.
We would have never been able to figure that out in pre-cal. I would have lost you guys in just the factoring alone. Nasty? Yes. Right? Yeah. If you would have graphed it, well, number 1, you would have only seen this little piece because you would have graphed a 10 by 10 window. You would have had to have made your Y min lower. But whew, there he is. Is he concave up and then concave down and then concave up with points of inflection both here and here? Yep. And I have my 1, negative 27, and I have my 2, negative 16. So, you guys still like polynomials?
Nope.
Me either. At least not 4th degrees. Dun 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 dun. Let's go find somebody who's not a polynomial. Would his derivatives have been gross? Yeah. But that's why I gave them to you. And that's all I'll give them to you next Wednesday, too. Do you need to know how to take derivatives for the final?
Yeah.
Mm-hmm. You need to know your derivative rules for the forever final.
Oh, yeah.
But you need to find derivatives for next Wednesday and section 3.5 problems. Okay. How easy are intercepts going to be?
So easy.
So easy, because isn't it just like, I can see him, he's right there, he's right
I
there.
can see clearly.
The rain is gone until tomorrow. Good thing it's not going to be
Hopefully
Beach
the
by
rain
Friday.
sparkles.
Oh, yeah. Is this on the forecast for, is it Wednesday and Saturday? Or is it Wednesday and Friday?
It says Wednesday and Thursday, and then Friday it's not supposed to.
Y-intercept is 0, 2, right, guys? Vertical asymptotes. Why am I saying them?
There's no room.
These two show up where? In the... They're discontinuities, and discontinuities are seen in piecewise function separators and fraction denominators. Is this a piecewise?
Nope.
Is it a fraction?
Nope.
Oh, sweet. None. If there's no denominator, how can a degree test on the bottom tie or win? None. Oblique asymptote. Long story short. Some of you might get a little confused saying x to the 1 over x to the 0 is 1 higher, but pause. This x has an additional x to the 1 half in essence. Anyway. If you guys plug in a negative x, opposite, change, and it's inside square root, and I can't. Awkward, there's a lot of nuns. Domain. There were no holes, there were no vertical asymptotes, but why am I going to say that this guy has to be only from negative infinity to 4? Why am I stopping at 4? It's a square root, and if I go higher, I'm going to have imaginary numbers. It's a different type of domain problem. Which means when I'm over here doing increasing, decreasing, I'm going to be stopping at 4, right? And for my concavity, I'm going to be stopping at 4. Something to keep in mind. Hey, why am I going to be plugging in subtract an 8, divide by negative 3. 8/3. Is that in my domain? Yes. Where did I get it?
By solving the pitchfork.
Why did I ignore the bottom? Well, he's my domain. I'm using 4 anyway. He's the boundary. So I only got 1 additional. 8/3. Hey, while we're setting everything up, why don't we find our pips too, yeah? Where are pips going to be? X equals?
Yeah, that there we go. 16.
Add the 16, divide that. But why am I going to cross him out and say rip?
Too big.
He's too big. He's 5 point something. He's not on my. Oh, I guess there's only 1 concavity. If there are no pips, I guess there are no points of inflection. You doing okay?
Yeah. Well, of course it's not going to be any inflection. Because
It's a square root. He's thinking of it's times x. I wonder what that is. Oh, don't worry. We'll figure it out right now. Okay. Plugging in the derivative, something less than 2 and 1. Okay. Or 0. Even better. 0 is a positive over a positive. How about 3, though? 8 minus 9 is a negative. What do I have at 8/3?
a relative max.
And why am I going to make an actual point? I want to put it on the graph.
Right.
So to come back here and say, ooh, what happens when I plug in 8/3? F of 8/3 for my relative max is equal to 8/3 times the square root of 12/3 minus 8/3. I'm lazy. 12/3 minus 8/3 is 4/3. Square root of 4 is 2. 2 times 8 is 16. 16 over 3 root 3.
Disgusting.
That's true.
That's true.
I can listen to that one. The pain isn't always bad. Not to pursue pain, but to be able to persevere through pain. If I go plug in the second derivative, something like 0, ooh, that's a negative number. Negative, that means concave down. All right, I got a lot of clues. Let's go see what we can do. I have some points. Yay! 0, 0. 4, 0. 8/3, which is 2-ish and a little bit more. 16 over square root of 3 is 1.72. 1.7-ish times 3 is 1 carry the 2, 5.1. What's 16 divided by 5-ish? 3-ish. So we're going to go 2 and a little bit more and 3 and a little bit more. Okay, fine. There's my disgusting 8/3 and 16 over 3 rad 3. Oh, and that's a relative max. I'm done. Wait. Am I? I'm concave down. I'm not going past 4. What else do I need to do, though? How long is he increasing for?
Oh.
Ooh, that was a bad increase. We'll go this way instead. Dun, 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 dun. Adam, what's that?
Isn't like the 8/3 like a total or no, never mind.
16/3 was a possible, but
It's too big.
okay. That was so much faster than the polynomial one. What would have been disgusting?
Doing them.
Getting those derivatives simplified. Which is why it's kind of nice this section is in this part of the chapter and not the last part of the chapter, where I would have still been proving the point that getting derivatives simplified is hard and we need practice. But wait a minute. We did how many examples of 14 identifies?
2, 3.
Mm-hmm.
Yes,
And I think you guys have 14 homework problems. But wait and pause. We have a couple minutes. Adam, are all 14 identifies? Does the book even say use 14 identifies? So let's peek at homework and see where the 14 identifies are necessary, because if you just notice up here, there's maybe a problem that says something like use a computer algebra system. Where does homework start off? What do you guys notice about this whole first huge section where I've given you 2 problems? 3 problems? I think I didn't circle them all. Oh, 4 problems? 5 problems? I gave you a pink. No, I didn't give you a pink one. Oh, here we go. We have 1, 2, 3, 4, 5. Okay, 5 problems. What do you see up here in the directions, guys? Analyze. How have I told you to analyze a function leading to a graph?
14
identifies. So, do you need to write all this? No. Just say graph with 14 IDs and check
Verify.
with a graphing calculator. How do you check it? Are you right? Sweet. Put a check mark. Done. Okay. That's this section, and then we go on to the weird one, I think. Yeah. The weird one that I have an example of up on your notes. Okay. Auxilio. When it says a computer algebra system, what is it telling you to do? Graph it and just tell me about it? No. It's saying, look online, Wolfram Alpha. What's F prime? Steal it from Wolfram Alpha. What's F double prime? Steal it from Wolfram Alpha. What are the zeros and DNEs? You can steal it from your graphing calculator if you want, but are you still doing 14 identifies? Yes, but you don't have to do the by hand work. Wait, am I making you do by hand work there? Is this really that different? No. Basically, it's just saying you can use a computer, you can use a graph. And then, guys, they're all 14 identifiers. Pretty much. Just some of them show up, like trig functions show up in a different section. But you do have a couple at the end that are concept-y ones. So 14 identifies all the way up to number 41, which is pink. You're welcome. I'll write a quick comment in there and tell you exactly which ones to do 14 identifies. But you guys will notice. The end of homework is more concept-y and less work. Which one are you going to choose? Kathleen, you look so comfy. I am so jealous.